Hey everyone, in this video, I'll be talking about how to set up indexing inside Postgres. If you have already looked in my previous video, I've talked about how indexing works. In this video, I'll be showing you how to set up indexing inside your Postgres database. We'll see how to analyze queries and see how indexes actually speed up queries by quite a bit. Before we try this out, I'll execute a particular helper function. This will make it easier for me to generate data. This particular method generates a random string of a given size. I'll mention it in the description. Feel free to check it out. Now that this is done, the next thing that we'll do is we'll create a table. So over here, I've created a table called employee, which has an ID, which is a serial, and also it is set as the primary key. Other than this, it has another column called name, which is a varchar of 20. Now that this table is created, let's observe this /d employee. As you can see, it's just a basic table with two columns. Now to enter data inside this table, we can use insert into employee name values, and we can give a name. Over here, I have given a Sam. I want to show you the power of indexing when you're dealing with tons of data at the same time. That is when you can see the beauty of indexing. Now, inserting element by element would be very difficult. So what I'll do is I'll run a query. It will generate a lot of random data for me. I'll add 1 million entries. For this, I'll run this query using the helper function that we created earlier. Insert into employees, name, and we'll select a random string 1 million times and enter it into the table. This will take some time. Now that this is done, I'll select the data from the table and just show you just to see what is there. We'll do select star from employee, limit 10. As you can see, the ID and a corresponding randomly generated string of length 20 is present over here. There are 1 million rows inside the whole table for all of these items. Now, we would be looking at a few queries and seeing how they perform. To check performance of queries run inside Postgres, you can use this command /timing. If you do this, every query that you run, it will show you how much time it took for the query to execute. Take, for example, the query that we ran back again. If I run this, you'll see it took 22 milliseconds. Now let's run a query and analyze it using explain analyze. What explain analyze does, it basically shows you what is the query plan which is present for the particular query that you have written. So for us, the query over here is select ID from employee where ID equal to 1000. Now you might say ki a query, why am I searching for ID when ID is already present over here? Now, this is related to a particular concept called covering indexes. I won't be covering it in the video, but this is something I'll cover probably in the future. Explain analyze, what it does, it shows you the query plan. Over here, you can see index only scan. What this means is the data got fetched directly from the index. The database did not have to go to the actual table or the heap of the actual table to fetch any kind of data, which is demonstrated over here. There are no heap fetches present. This took, all in all, the planning took 0.949 milliseconds and the execution took 5 milliseconds. As you can see, this is very fast. Next thing that we'll do is we'll check the same query, but instead of using ID, we'll fetch the name. As you can see over here, we fetch the name and use the ID for searching. Instead of it being an index only scan, it now became an index scan. And as you can see, the time for execution has grown by a little bit. Let's try something different. Let's try to search employee table using our employee name. To do this, let's actually first take out a random employee name and let's put a limit of maybe 1456, suppose. Over here, we'll put up a random one, this one, suppose. We'll run using explain analyze a query, which will now search by the name. Let's try this out. As you can see, this query took much longer than the query that we did using ID. It's almost multiple times slower, as it's demonstrated over here. The gather means that basically the database is searching through the whole table. Postgres does some internal optimizations. Workers mean it tries to optimize using parallel scanning. Basically, it will divide the table into maybe two sections, and there will be two workers who are searching parallelly using in different threads on both of them at the same time. But all in all, this was a sequential scan which happened on the employee table, and the execution time took much longer than the search time which it took by ID. If you remember, the ID took in the order of single digit milliseconds when we are searching both name and ID by ID. Another query that I would like to show you is using like. Example, externalize select ID from employee where name like percentage Z percentage. Let's try this out. If you can see over here, the execution time is quite high. It's still in the order of triple digit milliseconds. And this is because like queries, you still need to do a sequential scan. So this sequential scan would happen throughout the table. And again, the database engine has to go line by line through the whole table in order to resolve this. Hence, it taking this much amount of time. Okay. Next thing that I want to show you now, we'll create an index on the name column of the employee table. Before we do that, let's look at the externalize query again and just keep it here. As you can see, this was probably fetched from the cache, so the number went down by a little bit right now. But still, this is a lot on the higher side. So now let's create the index on the same column. So it would be create index idx name underscore employee on employee name. If we do this, it will take a little bit of time for the index to get created because of the large number of rows that we have in this table. Now that this is created, what we'll do is we'll run the same query again. If you see, the amount of time it took for the entire query to run went to double digits, from triple digits. It became almost like 10, 20 times faster. Let's see if this has any influence on the like query. As you can see over here, it's still a sequential scan. Creating an index definitely helped out when you are searching by the full name. Indexes work very well for numerical columns, for worker type of columns, etc. And this is how you would basically set up basic indexing inside your Postgres tables. Thank you.